Hello friends, today we are going to talk about periodic table. As you know that scientists have gathered a lot of information about various elements, so they have arranged it in a definite order. But this arrangement doesn't last within a single day. Rather, it takes a long time to rearrange it, and several journey have been started by them. The periodic table is managed by International Union of Pure and Applied Chemistry, or you may say it's IUPAC, in which it assigns lanthanoids and actinoids and grouping numbers from 1 to 18. Let's come to the journey of modern periodic table. But before the beginning of this modern periodic table, our scientists they passed through various type of trials. Let's begin. The first attempt is Dovernier's trial. Dovernier, a German chemist, tried to arrange the elements with similar properties into groups. He identified some groups having three elements each, so he called them as triads. He showed that three elements in a triad were written in the order of increasing atomic masses. The atomic mass of the middle element was roughly the average of atomic mass of the other two elements. It can be better explained with the help of example like lithium, sodium and potassium having atomic masses of 6.9, 23 and 39. The average of the atomic masses of lithium and potassium is equivalent to that of sodium. Next is our Newland's law of octaves. According to this law, every 8 element had the properties similar to that of first, as you can see in the figure. He compared this to the octaves found in music. So it is called law of octaves. It is known as Newland law of octaves. Here the properties of lithium and sodium were found to be the same. Sodium is 8 after lithium. Similarly, beryllium and magnesium resemble each other. According to Newland law of octaves, only 56 elements existed in nature. Later, Mendeleev started his work when 63 elements were known. He examined the relationship between atomic masses of the element and their physical and chemical properties. Mendeleev periodic table, vertical columns called groups and horizontal rows called periods. According to Dmitry Ivanovich Mendeleev, a Russian chemist, the properties of the elements are the periodic function of their atomic masses. He further includes that the elements like oxygen and hydrogen are very much reactive, but in the latter half a new periodic table come into existence which is known as modern periodic table because there are certain limitations to Mendeleev classifications of elements, and alkali metals like hydrogen combines with halogens, oxygen and sulfur to form compounds having similar formula, and halogens like hydrogen also exist as diatomic molecules, and it combines with metals and non-metals to form covalent compounds. So, the modern periodic table are based upon the atomic number of an element, which is a more fundamental property than its atomic mass. There are many trends in modern periodic table like valency, atomic size, metallic and non-metallic properties, etc. Thank you. Hope you all like this video, share and subscribe. Thank you. Let's come to the first trend, valency. Valency of an element is determined by the number of valence electrons present in the outermost cell of its atom. Next is atomic size. The atomic size refers to the radius of an atom. The atomic sizes may be visualized as the distance between the center of the nucleus and the outermost cell of an isolated atom. The last one is the metallic and non-metallic properties. Metals like sodium and magnesium are towards the left hand side of the periodic table, and sulfur and chlorine are found on the right hand side of the periodic table.